Okay, guys, as promised, we're going to talk about systems of equations. Your paper looks like so let's fill in our notes. What is a system of equation? It is when there are two or more equations and they have the same variables. When we're talking about an answer or a solution to a system, there could be different scenarios. We talked about those today or yesterday. And once we graph these, if they intersect, then the point x comma y is where they intersect. So that becomes the solution. We'll talk about that in a moment. Algebraically, the point xy that will make both of my equations true. So we can also practice just looking at some example answers and saying, will this or will this not make it true? So we have intersecting lines. That could be a system, and here is where they intersect. And that will give us one answer with some sort of number, like 2, 3. We could have parallel lines. We talked about this today. There's no solution because they never intersect. And we know no solution symbol looks like that. We've used that before. And when they're the same line, remember the equations might look different, but they are over one another. And that has an infinite amount of solutions because they intersect at every single point along the line. Okay, when it comes to this part for the notes, what are the steps we need to take? First of all, we want to make sure we write or solve the equations to be in slope-intercept form. So I'm going to write it, solve it so that it is y equals mx plus b. Secondly, graph your lines. We're going to have 2 lines for our problems, so graph both lines. And then we are going to identify the solution. Solution means answer. And that answer will be where the lines intersect. Okay, kind of like we just did in the beginning there. This is where they would be intersecting. So let's take a look at this first problem. And as you can see, this is in y equals m would be 1, x plus b. So we're ready to graph this one right away. So we're going to use our intercept of -8. 1, 2, 3, 4, 5, 6, 7, and 8. Then we are going to look at the slope. 1 is a whole number, so 1 over 1. So we're going to go up 1 over 1, up 1 over 1, and make sure that it's going in a positive slope. Draw your line to the best of your ability because where it crosses is going to be really important when it intersects the other line. So here, this one's in y equals mx plus b as well. So the intercept is positive 1. And here our slope is -2. So -2 over 1 down 2. And in which way for a negative slope? This way. Down 2 over 1, down 2 over 1. And so what I would do is I would continue to graph until I can see it's going to hit my other line. And as you can see, it hits right there. So I've created my graph. Now I need my solution. So the solution will be this point. So we're at 1, 2, 3. So we're at positive 3 on the x. Then go down 1, 2, 3, 4, 5, comma, -5. Now, does it matter the order? Absolutely it does, right? Our values go x, then y, right? That's how we would get to that point, and that's why we've been practicing graphing so much. All right, let's try another. So again, this one is in slope-intercept, y equals mx plus b. So let's go up to 9. 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then our slope is a positive 1/2. If I don't want to go up, I can also go down 1 and over 2. We want it to be positive sloping, so it's going to be this direction when I'm going down. 1 over 2, down 1 over 2. Okay. Be as accurate as you can. Maybe you want to go up 1 over 2 here as well. Okay, let's take a look at this one. Y equals mx plus b again. So this one is very kind to you. So -1 for your slope and 6 is your intercept. 1, 2, 3, 4, 5, and 6. This is going to be a negative slope, so it's going to be going down. So down 1 and over this direction. So since this line's over here, I'm going to reverse it and go this way so I can figure out where I'm going to make it to. Up 1, back 1, up 1, back 1, and there it is. Okay. So my solution, how do I get here, right? I always do my x first. Looks like it's on the -2, right? Here would be -1. Here's our origin, so -2. And then how vertically high? This one was 9, so that's an 8. So comma 8. And that's our solution. Okay, let's take a look at one more example. So here you'll notice that we do not have equations in slope-intercept form. I'm sure you could see that coming. So we need to first do some work. I would use my notebook, so I have space and I can be accurate, to convert these into slope-intercept form. So we want y to be by itself. So we need to move this 3x term. It's a negative, so we're going to add 3x to both sides. And now we have y equals 8 plus 3x. If it's helpful, let's rewrite it to say y equals 3x plus 8. All right, we're in the perfect slope-intercept form. Let's look at this one then. -x plus y equals -2. So we just need to move this x term, and it's a -1, so we're going to do plus 1x. And now we have y equals, and let's go ahead and write the mx part first, minus b plus b. All right, let's graph it. I'll start with this one at -2, +1 slope, up 1 over 1. Okay, I'll leave it there for right now because I don't know where the other one is yet. So I need an intercept at +8. +8 and a positive slope. So we're going to go, let's go down 3. 1, 2, 3, and over 1 to make it positive. Down 1, 2, 3, and over 1. 1, 2, 3, over 1. 1, 2, 3, over 1. Let's continue our red line. Down 1 over 1, down 1 over 1. Getting close. Haven't found my intersection, point of intersection yet. Down 3, 1, 2, 3, and over 1. Woo, there it is. So that one took a while for us to find it. Okay, not the best line, but you get the point. So we need to find our solution. It's at 1, 2, 3, 4, 5, -5. And down 1, 2, 3, 4, 5, 6, 7, -7. Okay, good luck. I'd say the most important part is to get your equations accurate so that you can graph them and find their points of intersect. Now, I will give you a heads up. There could be the instance where you might have 2 parallel lines get graphed. If that happens, they have the same slope and they will never intersect, and so we would say that there's no solution. If, however, you also graph a line and then you start graphing and it's the exact same line, then you're going to have an infinite amount of solutions, like we've talked about yesterday, because they become the same line. They just possibly look like they're a different form. Last thing is that when you get to IXL practice, you'll notice that there are two colors here. When you're clicked on one of the colors, that line will show up with that color. So you're going to graph here. So once you did this, you would go to your intercept of 4 and click on it, and then it creates that dotted line that lets you start to create your line. And then you'll use your slope down 3 over 2. Create a negative, and you'll click in and lock in, so that becomes a straight line. It'll do it for you. Then you need to go over here and click on this one, and it'll become the other color. You'll click your intercept, up 1 over 2, up 1 over 2, okay, and you'll see, and it'll automatically lock in and show you where they intersect. And then you will have to also right here put in the point that is